Thank you. Can you hear me well? All right. I feel like Lady Gaga. My name's Ari Vanderhoeven. I'm an architect with the OEM consulting team at Microsoft. I also work very closely with Tony Mangiafesti, who many of you know, and the Windows team at Microsoft. I originally came from the kernel team at Microsoft, where I spent 10 years. Today we're going to talk about UEFI implications for server, but almost everything here is also value add for client. And what we're really trying to do this year, Windows 8 made UEFI a requirement for client, so we had an enormous push. And that was across UEFI, but also technologies like Secure Boot, integrating TPMs. There's a really big effort founded in security, but also had a lot to do with the new UI, the new seamless boot, the new user experience with Windows 8. So today we're going to look mostly at the features that apply for client, but also across server. We're starting to see the server industry now move in the direction of UEFI, and it comes with a different paradigm, a different perspective. And keep that in mind as we're going through these slides. We'll start by looking through, and we'll spend quite a bit of time today looking through the feature set, what UEFI provides in Server 2012. Then we'll look at some boot flows, which are very different for UEFI, and that has implications for server. Look quickly at certification, some challenges. We'll talk about UEFI driver signing. And then finally, we'll have some resources and Q&A. And you can either ask questions today, or we're now manning the Microsoft room down on the 13th floor, and we have a sign-up sheet on the door. So if you want to come discuss something with Microsoft, or we have a lot of presentations we've been giving, training we've been giving, please feel free to sign up and come talk with us. This is a slide I've given many, many times before, and it talks in general about the advantages of UEFI versus BIOS. We're familiar with them. I'd say the biggest ones for server are around runtime services. In Windows now we have the get set variable APIs, so you can call into UEFI services from a runtime OS, which you couldn't do with BIOS, of course. Also, you now have a driver and app model. And in the server space, when we start thinking about management applications, we start thinking about security in the server space, suddenly having a firmware driver model is really powerful. So I'm going to start going through some of the features, and I'll start with one that began being supported in Windows Server 2008, and this is Multicast Support. You only get this with UEFI. With Server 2012, you must support IPv4 and IPv6, which was a large part of the testing we did here a year ago. A year ago, we brought Microsoft Server and the ability to do testing, because Multicast and IPv6 and Pixie Boot were some early challenges with UEFI. Now in a data center, you have the ability to use, with UEFI, you have the ability to use WDS Multicast so that you can take one image and send it simultaneously to many different targets without overwhelming your network. So that's basically how Multicast works. In some situations, this alone could be motivation to move, especially a data center type of environment, to UEFI. So what else? What else do we have? Of course, Secure Boot. I'd say Secure Boot is, when we talk to someone who's in the server business, they're either not interested at all or they're very interested. If they're very interested, it's usually because they've already talked to a client who's in the security space, financial institutions, governments. People are very worried about malware, especially in the boot sector. So for some, the light's gone on. We expect Secure Boot to also become a play in the server environment. Along with Secure Boot, we're going to start having new conversations about things like, what if you have a VMC and you want to manage Secure Boot remotely, but today's requirements are that you must, if you're going to disable Secure Boot, you must do it with physical presence. We're very open to those types of discussions, and we're excited to have them. So there's a different paradigm as we start looking at secure boot into the server space. And this diagram here shows the entire what we call trusted boot stack. You know, secure boot is really just this handoff between the UEFI bootloader and the OS loader. If you have a TPM, secure boot doesn't require a TPM, but if you have a TPM, we're recording secure boot policy, and then you also have the ability to track that policy and enable measured boot. Now all this comes with Windows Server 2012 and Windows 8. Measured boot allows you as a client to attest to the network that, hey, I've booted securely, I've even booted with secure boot on, I've launched my anti-malware software early, everything is checked out clean, and all the measurements I've made in my platform configuration registers check out. Now I can join the network. And that would greatly help us in some of the Windows exploits. I brought up a rootkit that was used in the Stuxnet attack when we presented on this topic back at the summit in Redmond in the summer. And things like those types of rootkits can be detected, and then those machines delivering those viruses are not able to deliver into your network. So there's a lot of work that's been done with security, and it does apply to server as well as to client, and it all relies on UEFI. When we do a full training, this topic alone is usually over an hour. There's quite a bit. If we go into TPMs, that's another hour. So there's quite a bit of detail on any of these topics. Again, if you're interested, we've got the decks, we've got time. Please sign up at the Microsoft room. EDrive support, encrypted hard drives. Not that interesting for server, except that as the technology moves forward, we expect most hard drives to sell at some point in the future to all be eDrives. And the advantages of an eDrive or an encrypted hard disk drive are that you have the encryption in the hardware itself. That saves you CPU cycles. It also means you can instantly Bitlocker protect or instantly provision a drive. It doesn't take any time at all. So if Bitlocker becomes popular in the server world, then suddenly features like this become very popular. This relies on UEFI. You must implement UEFI if you're going to implement Microsoft's version of encrypted hard drive support. And you know, there are many companies today who have actual physical grinders on site, where if they're disposing or decommissioning a drive, they actually have to rip it up. And we believe with Bitlocker support, that's not necessary. You can make sure that that drive is uncrackable were it to end up in a garbage dump somewhere. Also relating to Bitlocker is the ability to Bitlocker protect a drive, and this is new in Windows Server 2012 and Windows 8. The ability to Bitlocker protect a drive and unlock it automatically if it's connected to your network via LAN cable. So you can imagine if, say, I wanted to move my server farm to Bitlocker Protection as part of my security policy, but then I wanted to reboot a system. You know, with Server 2008, I have to go and send a technician and hit the PIN code physically on every machine. And starting in 2012 now, we store the keys in Active Directory, and you can automatically, as long as you're connected to the network and on the domain, automatically reboot the system and automatically retrieve the key from Active Directory. But if I were to take the server, unplug it, and take it off premise outside the building, that data is still Bitlocker protected. Okay, this one I'm kind of cheating because this is the one feature that doesn't rely on UEFI, but it always comes up in the topic because it's new with Server 2012 and it has to do with boot. And that's the ability to do a very fast hybrid boot. And this was designed for client. Fast boot is a big part of the Windows 8 experience. But what's interesting is when we start talking about boot, and they're often talking about boot and UEFI together, suddenly we get server vendors and server customers who want the ability to quickly boot their servers to reduce downtime. So they have high availability. part of the reason for that is if I have a large number of servers, often I'm overutilized and I want to power down a large number of servers. In turn, I want to be able to quickly bring them back up when needed. Hybrid boot is a technology, whereas on shutdown, this is showing boot up, but on shutdown what happens is we close all of session 1, most of session 1, and then we take just the core session 0, basically your boot critical components, your kernel components, your hardware configurations, your boot services, and we take that information and we create a very small, usually 100 megabyte to 200 megabyte compressed hybrid file. It's a small hybrid file. It's not like Resume. Then on boot, we post and we decompress and restore memory in parallel. A lot of work was done with this, again with client in mind. We also can do it multi-threaded. So if you have 4 threads or 8 threads or 20 threads, we're using all available resources now to boot as quickly as we can, restoring that hybrid file, and we're decompressing and restoring at the same time, and that allows us to boot much more quickly. Something else you get with UEFI, of course, is update capsule support. And there's full support in Windows 12 for using update capsule as a standardized way to update firmware, which is as valuable for a server platform as it is in client. We have a well-accepted model. I think this diagram is one we've shown many times before. But we can even sign your update for you, or you can sign it yourself, and then use update capsule to have a very standard way of managing updates, making sure you're also complying with Windows requirements around secure firmware updates, which require that you keep track of versions. And in this case, with update capsule, there is the EDrive system resource table in ACPI that allows you to track which updates are security updates and which updates aren't, because you cannot roll back a security update. And this is kind of a catch-all. When we start hearing about UEFI in the server space, we run into the remote management story we were talking about earlier. You know, what can I do to remotely manage my systems, enable secure boot, security. You now have an app model that's consistent. We also now have ability in the OS runtime to use, again, get and set variable APIs to call into firmware, and you can certainly make your firmware menus a lot richer. You know, you have the graphic GOP interface. You can have a very rich graphical interface in your BIOS menus. And as we start looking into this, you know, we are seeing movements towards doing a lot more management software that can be consistent across both Windows and Linux. We're also getting a lot of questions around Windows requirements versus things that server customers want to do. Those are discussions we're very, very happy to entertain. We want to have those discussions, and we're really seeing that heat up this year. We're seeing a lot more interest from server this year. Something else I think the industry is beginning to realize is now all the tool sets, all the IP, the EDK2, everything that's happening in the industry is making investments in UEFI and no longer in BIOS interfaces. So even if a server OEM wanted to stay with BIOS, they would certainly now be on their own, and they would become the outlier. And over time, if you're an enterprise or you're a business, you really want to invest in standard technologies where the industry is going. So we see a lot of momentum as well, moving the server industry to UEFI. For the people in this room, that means there's opportunity. You want to start opening your ears. We're beginning to hear it. You're probably beginning to hear it as well. This is also where the differentiation comes in. You know, what can you do? We've seen some differentiation for client. What can you do as an industry, as the UEFI members, to really light up some scenarios that are going to sell well in the server space? And there are better margins there. So if you're going to take a picture of a slide, this is a good slide to take a picture of, because Usually it's difficult when say I'm a BIOS engineer with a server, or I'm somebody who's purchasing systems, and I want to know, well, what do I get with UEFI versus BIOS? And if we start over here in Windows 2008 R2 BIOS mode, really nothing. You get nothing, and then if you flip to UEFI, you get support for greater than 2 terabyte disks. Not important for server today, but will be soon. You get multicast support starting Windows 2008. And of course you get GOP and UEFI drivers and apps, but not a lot of Windows value add. The Windows value add really happens here. And this is where, really I'm looking back at all the features I presented. I added a few more. In a moment, we'll go through some of the boot paths, because you now have the ability from UEFI to call runtime services or the boot service to reboot your systems. You can do it remotely and reboot into a different path, like rebooting to the network, for example, for Pixie Boot. We have all the security features, support for TPM 2.0, required for connected standby today with Windows, but we see it as the future for TPMs, and we do think Microsoft Windows, we do think TPMs are important for servers as well as for clients. The future of TPM is 2.0. So quite a rich set of features just in one OS release, one generation. So you can imagine how quickly this is going to grow over time and how much richer the feature set is going to become. So these slides will be available on the UEFI org site later, and I think this slide right here is a very good summary of everything you get as you move to newer operating systems, both with Windows and with other operating systems as well. Okay, this is tough, but when we start talking about UEFI, part of the hesitation is all the different boot paths, and this was part of our struggle with client as well. The Windows client idea now is nothing happens during post. You don't hit F2, you don't hit F12, you don't hit F10. If you don't boot correctly, we'll send you to Windows RE, where you can get to all your startup menus, and you can eventually use those startup menus to then boot either back into your firmware UI, or to USB, or to DVD, or to Pixie. But everything happens in the OS, nothing really happens in post. With server, for server we still expect there to be legacy behavior. It's okay on a server to still hit F2 or hit F10 to enter your BIOS or to Pixie Boot or something else. That being said, you now have the ability to, from the OS, to either use UI or APIs to automatically boot into firmware UI or to boot into some kind of UEFI application. So this gives you an idea of what you can do from the OS side. And I probably should show some of the APIs here as well, since I'm talking server. This is a client slide. You can now reach back into firmware, and you can service systems. You can use this to update firmware. You can use this to do security audits that require you booting into a UEFI application. So lots of opportunity here. Also, and this is one thing we always remind people, is there's also a lot of validation here, a lot of firmware validation. The good news for server is that a lot of the firmware has already gone through the pain with client. So these days, if I do see an issue on server, almost always I've seen it before on client. And I know this because I help support the GFS folks, the folks who run the Microsoft-owned, Microsoft-built data center PCs. And often, if they come to me with an issue, I know it from the client side. This is a quick look at the OS indications variable that we, with help from Intel and HP and others, introduced last year into Errata C. For Windows 8 Client, this is a very easy way of implementing something that allows you to go into a UI menu in Windows and choose to reboot into your firmware menu. OS indications is also something that can be extendable moving forward. So this is the type of behavior that we expect to become more common. This is just one example of it from the client side. Boot to devices, again, same example using boot next in UEFI. Something else that can be leveraged on the server side. Also something where server needs to think about making sure they have the proper strings, and they need to make sure they have the right boot entries in NVRAM, and that the strings are correct. We have some guidance on that in our Windows 8 boot experience white paper, and I believe that's on Connect, but I believe we also have something now on MSDN that prescribes how to do this. For client, in our ADK, there is a piece of the Windows UI that if you go into the troubleshoot menu from advanced options, boot options menu, you can add your own utility now. You can add one. On client, it's almost always used for a third-party or OEM-owned recovery environment. So if you want to use, instead of using the Windows RE recovery environment, you have your own recovery environment. This is your way in. That being said, it's real estate for the OEM. So you can go into the ADK and look at other uses for this OEM-owned UEFI application. Just a quick look at certification. You know, the WHCK, UEFI is not required for server. I don't know of plans to make it a requirement for server. I think it's going to be more of the industry moving that way, not like we did with client where we said we have to move this way because of security. That being said, if you implement UEFI, you have to support obviously GOP. So you must support GOP if you're doing UEFI, which is a no-brainer. Make sure you can boot to all the different options. The boot to firmware menu is not a requirement, but it's a nice thing to implement. And then feature by feature, if you start implementing Bitlocker, there are quite a few requirements in the HCK, quite a bit of validation to do, and again with secure boot. Long list of requirements that fall under here. That being said, just going to UEFI should be relatively painless. Not a lot of new requirements there. Finally, servers can, you can, if I'm a big OEM, I can trust myself and add my own cert to the database and always run my own utilities. But if I want to have some kind of UEFI driver or application that is used more broadly in other systems, in that case, I may want to take advantage of the Microsoft driver signing service, which we'll show on the next slide. Of course, if secure boot is enabled, which we're encouraging, then all drivers must be trusted and must be signed. They can be signed by a key or certificate authority in the database, or, and this is often what we do when we're testing something with secure boot, just add a hash into the DB of that application or driver. This doesn't apply to the core firmware itself. It's part of the image you upgrade. That's what secure firmware updates are for. That's what guarantees the security of your core firmware image. Now, if you're a member of Dev Center, a lot of people know this, you can submit your driver so that if the system, and we encourage and recommend that most client systems have the Microsoft UEFI driver signing certificate in the DB. It's recommended but not required. Some of us now wish we had required it because it's very important for things like booting to Linux now. But that's our model for supporting UEFI applications that we have looked at and trusted, and then running those across systems. We're also going to recommend this for server as well. And again, there are a number of rules. At first we were doing automatic signing, and now we realized we need more of a process. We need to look at, ask questions, making sure we're not signing something that later we would have to revoke because because there's some kind of security threat. So again, if you go through the process, we'll examine the drivers twice a week. We try and give a relatively quick turnaround, but we may have some questions around relating especially to security. Okay, large number of resources, starting with the certification requirements, which are now up on MSDN for Windows Server 2012. Windows Dev Center, this is where you go to sign up to be able to submit drivers and applications for signing. MSDN, again, is a very big resource for everything, and we're still getting new information out relating to Windows 8. A lot of it was on the Windows Connect site, and was always visible to OEMs and IHVs who had Connect accounts. We're now moving more and more of that to MSDN. And with that, I spoke very quickly, so I am actually on time. I'll open it up to Q&A if you have any questions now for the room. But also, again, feel free to sign up at the Microsoft room on the 13th floor, and we can arrange to meet with you later in the week. So do we have any questions in the room? All right, thank you very much.